Hello everyone, I am Dr. Vidya Patil, Associate Professor, Department of Mechanical Engineering, in Reverted Institute of Technology, College of Engineering, Yadrao. In this session, we are going to cover the gear train in reverted gear train and epicyclic gear train. So, in this under the subject Fundamental of Mechanical Engineering for first year mechanical engineering students. So, in this session, we are going to cover the epicyclic introduction of gear train, types of gear train, reverted gear train and epicyclic gear train. So first we see the introductory part of the gear train. So gear train is the combination of gears used to transmit motion from one shaft to another shaft. It becomes the necessary when it is required to obtain large speed reduction within a small space. A gear train is a mechanical arrangement of gears that transmit rotational motion and torque from one part of machine or system to another. It consists of two or more gears meshed together, forming a series of interconnected rotating elements. Gear trains are widely used in various applications including automotive transmissions, industrial machinery and clock mechanisms. So, gear train is the mechanical system consisting of two or more gears arranged to transmit motion and power from one shaft to another. So, gear trains are widely used in machines where specific speed ratio, torque, transmission or change in direction or rotation is required. Since gears mesh directly with each other, they provide the positive drive without slipping, so making them more accurate and efficient than belt or rope drives. So gear trains are primary function of this gear train is to transfer power from a driving shaft to the driven shaft when achieving a desired speed and torque characteristics. When a smaller gear drives the larger gear, the speed decreases and the torque increases. Conversely, when the larger gear drives the smaller gear, the speed increases and the torque decreases. So, gear train can also be used to change the direction of rotation and to transmit power between shafts that are separated by some distance. So generally the main types of gear trains are simple gear train, compound gear train, reverted gear train, planetary gear train and differential gear train. We see in this session the reverted gear train. So generally the reverted gear train is the special type of compound gear train. In this gear train, the axis of first gear that is called as the driver and the last gear that is driven are on the same center line. You can see also in this diagram. Here total 4 gears are there. Gear 1 is meshing with gear 2. Gear 2 and gear 3, these are the compound gears because gear 2 and gear 3 are on the same shaft, mounted on same shaft. And gear 2 is meshing with gear 3, that's why gear 2 and gear 3 having the same speed, and gear 3 is meshing with the gear 4. These gear 1 and gear 4 having coaxial shafts. Okay, so the reverted gear train is a special type of compound gear train in which the axis of first gear and the last gear are coincide. In other words, the input and output shafts are located on the same center line. This arrangement is achieved by carefully selecting the sizes and positions of the gears so that the distance between the first and second gear is equal to the distance between the third and fourth gear. So, the main advantage of this reverted gear train is to compactness and the convenient arrangement of having the input and output shaft on the same axis. This feature makes it highly suitable for devices where the space is limited and coaxial shafts are required. So reverted gear train are commonly used in clocks, watches, lathe back gears and various gearbox mechanisms. Although they provide the high speed reduction in compact space, their design is more complicated than that of ordinary compound gear train and required precise manufacturing and alignment. So this is the unique feature of this reverted gear train, is that input and output shafts are coaxial, making the system compact and suitable for applications where the space is limited. So for the proper operation, the sum of the teeth of gear 1 and gear 2 must be equal the sum of the teeth on gear 3 and 4. So T1 plus T2, that is number of teeth on T1 plus number of teeth on T2 is equal to number of teeth on T3 plus number of teeth on T4. So again here we can see the reverted gear train. Gear 1 drives the gear 2. Gear 2 and gear 3 are rigidly connected on same shaft. So speed of N2 is equal to N3 means speed of gear 2 is equal to speed of gear 3. Gear 3 drives gear 4 and gear 1 and 4 are mounted on coaxial shafts. So if we want to calculate the velocity ratio for this reverted gear train, that time for the first gear, if we consider the first gear train or gear pair, that is gear 1 and 2, the speed ratio of gear 1 and 2 is equal to N1 upon N2 is equal to T2 upon T1. If we consider the second gear pair, that is gear 3 and gear 4, the speed ratio is equal to N3 upon N4 is equal to T4 upon T3. But the gear 2 and gear 3, these are the compound gears, that's why speed of the gear 2 and speed of the gear 3 is same, that's why N2 is equal to N3. If we multiply these two equations of first gear and second gear, we get the velocity ratio, that is N1 upon N4 is equal to T2 upon T1 multiplied by T4 upon T3. And here there is a speed, therefore the velocity ratio of this reverted gear train is equal to N1 upon N4 is equal to T2 multiplied by T4 divided by T1 multiplied by T3. So same velocity ratio is that is speed of driver gear divided by speed of driven gear is equal to the product of number of teeth on driven gear, so T2 and T4 are the driven gears, divided by the product of number of teeth on driver gear, that is the number of teeth of product of T1 and T3. So this is the velocity ratio for the reverted gear train. The advantages of this reverted gear train is that compact in design because input output shafts are lie on the same axis, so reducing the space requirement. Again, second advantage is that large speed reduction is there, so high velocity ratio can be achieved in relatively small arrangement. Coaxial input and output means convenient when the driving and driven shaft must be aligned. Efficient power transmission, this is suitable for transmitting power between shafts while maintaining a compact layout. Better balance, symmetrical arrangement often result in smoother operation and reduced vibration, and flexible gear ratio selection. So these are the advantages. Application, that is this reverted gear train is used in clocks, watches, automobile gearbox, lathe back gears, speed reducers, machine tools, printing machine. Okay, now we see the epi-cyclic gear train. So this epi-cyclic gear train is also called as a planetary gear train. So this is the one of the most advanced and compact form of gear transmission. In this arrangement, you can see in the diagram also, one or more gears are called planet gears, rotate about their own axis, while simultaneously revolving around the central gear known as the sun gear. The planet gears are mounted on rotating arm called the planet carrier. In many designs, in outer internal gear called the ring gear or annual surrounds the planet gear. You can see this is the ring gear, this is the arm, this is the middle gear is the sun, center gear is the sun gear, and these three are the planet gears. So the unique feature of this epicyclic gear train is that the axis of some gears are not fixed but move relative to the frame. This allows a large number of speed ratios to be obtained by fixing different members of the system and driving others. For example, here the sun gear may be the input and the ring gear may be fixed, and the carrier may serve as the output. So different combinations produce different speed reductions and speed increases or reverse rotations. So this epicyclic gear train offers several advantages. They are extremely compact, capable of transmitting high torque, and provide multiple gear ratios within a small space. Because the load is shared among several planet gears, the system operates smoothly and efficiently. These characteristics makes epicyclic gear train ideal or automatic transmissions in automobiles, hybrid vehicles, robotics, aerospace applications, wind turbines, and industrial machinery. But this design is complex design, higher manufacturing cost is required, and most difficult maintenance compared with the other gear train arrangement. So this is the epicyclic gear train, and these are the advantages we already discussed, that is the high speed reduction, compact space, coaxial input output shaft, high torque transmission capability, smooth balanced operation, multiple gear ratios possible from the same set of gears, and applications also we already discussed. So in last video also we seen the simple gear train and compound gear train, and this video we see the reverted gear train and epicyclic gear train. The main summary or the importance of these gear trains is the gear trains plays the vital role in mechanical engineering because they allow engineers to control speed, torque, and direction of motion with high precision. So their ability to provide positive and reliable power transmission makes them indispensable in a wide range of machines and equipments. So from simple household clocks to sophisticated automobile transmissions and aerospace systems, gear trains remain one of the most important mechanisms for power transmission in modern engineering. So the gear train is a system of interconnected gears used to transmit motion and power. So the four main types: simple gear train, compound gear train, reverted gear train, epicyclic gear trains. So simple gears used for moderate speed ratios, compound gear trains provide the large speed reductions. Reverted gear trains offers the coaxial input and output shafts, and epicyclic gear trains deliver high torque and multiple speed ratios in compact design. So each type is selected according to the requirement of specific applications. So these all gear trains are very important because the main objective of this gear train is to transfer power from driving shaft to driven shaft while achieving the desired speed and torque characteristics is achieved in these four gear trains. So smaller gear drives larger gear drives, speed decreases, speed increases. That is depend on different gear trains. So we already discussed that when larger gear drives a smaller gear, the speed increases and torque decreases, and gear train can also be used to change the direction of rotation and to transmit power between shafts that are separated by some distance. So all these points are covered in this session. Thank you.